Hello students, welcome back to today's class on real numbers. Real numbers is very important. Till now we have just learned what are natural numbers, what are whole numbers, what are integers, and from there we are going ahead to learn rational numbers and some more numbers, and then clubbing all these we are going to discuss what are real numbers. Right, my name is Avinash and I am a graduate from IIT Kharagpur. Let's continue today's class. So first of all, in the lower classes, we learnt what are natural numbers, the counting numbers. You count from 1, 2, 3, 4, right? So all those numbers comes under natural numbers, 1, 2, 3 and so on till. Is there any end for natural numbers? No. They just keep on going till infinity. Next, from natural numbers, just add 0 for this natural numbers, one more element 0, and we will be getting whole numbers from there. We get a whole numbers, and when you add all the negative numbers as well, we get integers. Right? Integers like minus 3, minus 2, minus 1, 0, 1, 2, 3. All these are integers. Correct? From integers, we learned what are rational numbers. Rational numbers, once again in today's class, let's discuss what are rational numbers. Okay, so from integers, rational numbers will look like something like 2 by 3, 1 by 4, 2 by 7. Okay, so all these fractions we can say are rational numbers, and we have few more numbers which are not rational numbers, which also don't come under natural or whole or integers. Those are called irrational numbers. Irrational. This black line tells that it is not coming from integers, but we still have more numbers like rational. We have something called irrational numbers also, and these two, rational and irrational, both together are called real numbers. That means in real numbers we have natural, we have whole, we have integers, we have rational, we have irrational. Clubbing all these, we say we have real numbers. Say, I'll tell you in another way. Natural numbers, let us say this is a circle natural numbers. Extended to 0, we have whole numbers, which is represented with W. This with N. Integers with Z. An extended version to this one, we have Z with both positive and negative numbers as well as 0. Right? From integers, we get what are rational numbers, which we represent with Q. And extended to that, we also have irrational numbers, which we denote with the T. Okay, which does not come under rational numbers. We have irrational numbers T. And now the complete set of all these numbers, are called real numbers, which we denote with R. Right? So let's try to have a small discussion about rational numbers, and then we'll go for the discussion of irrational, and from there we'll try to discuss some applications of real numbers. Right? So what is the first one we're going to discuss about rational numbers? So what is a rational number all about? What is a rational number? A number is said to be a rational number if it can be expressed as P by Q, where P and Q are integers. If it can be expressed as P by Q, something like 2 by 3, something like 3 by 4, something like 4 by 5. Okay, anyway, positive as well as negative. Where P and Q are integers, this P and Q are integers, but one more exception is there, that Q should not be equal to 0. What will happen if Q is 0? It will be like P by 0, like 2 by 0, minus 3 by 0. By zeros are never defined. These are undefined numbers. What is the value of 1 by 0? We don't know. What is the value of 3 by 0? We don't know. These are undefined numbers. Right? So let's move forward for the next one. 1 by 5, minus 8 by 15, 2 by 1. These are the examples. These are few examples of rational numbers. Okay? You cannot have 2 by 0 or minus 100 by 0 as a rational number. These are not rational, as well as these are not irrational also. Irrational we haven't discussed, right? Even there are numbers which does not come under rational as well as irrational, which is not a defined number. It is undefined. Okay? So let's move forward. Plot the rational number 3 by 5 on a number line. Till the lower classes we learned what are rational numbers, right? What are rational numbers? I mean to say, what is a number line, how to represent numbers on number line, how to represent natural numbers, how to represent whole numbers, how to represent integers. Now let's discuss about 3 by 5. So what to do for 3 by 5? As 3 is less than 5, as 3 is less than 5, okay, if you can remember from the fractions, this value will be a value between 0 and 1, because the numerator is less than denominator. So this number will always lie between 0 to 1. Any number of that kind. You can take 100 by 10 or 1000, 100 by 1000. Numerator is less than the denominator. It is always a value between 0 and 1. Positive. If it is negative, 0 and minus 1. Okay, so let's try to take 0 here and let's try to take 1 here. So 3 by 5 will lie somewhere in between 0 and 1. Will lie in between somewhere between 0 and 1. Okay, so plot the rational number 3 by 5. Now what you do, between 0 to 1, divide into 5 parts. Between 0 and 1, divide into 5 parts. First part, second part, third, fourth, and that is the fifth part. 1, 2, 3, 4, and that is the fifth part. Understand? So now out of these 5 parts, we have to take 3 parts. We need to take 3 parts. Or you can write like this. This is 0, right? 0. So this is the first part out of the 5. So this is 1 by 5. This is the second part, 2 by 5. The third part, 3 by 5, 4 by 5, and the last part, 5 by 5, which is equal to 1. Right? So where is 3 by 5? In between 0 to 1, if you divide that into 5 equal parts, you get the value 3 by 5 here. You get the 3 by 5 here. So this is the place of a 3 by 5. Right? Okay. Let's move forward for the next question. Plot the rational number minus 3 by 7. Once again, 3 is less than 7, correct? Positive or negative, that we'll see. But 3 is less than 7. So numerator is less than denominator. It is enough to say that it is a number between 0 and 1. But as we have a negative number, it is a number between 0 and minus 1. We have a number between 0 and minus 1, correct? Okay, let us give more place to write this one minus 1 so that we can keep how many parts we want. Okay, minus 1. Between 0 and minus 1, now we need to divide into 7 parts. Okay, so 1, 2, 3, 4, 5, 6, and this is 7th part. Okay, so this is 0 by 7. This is a minus 1 by 7. This is minus 2 by 7, minus 3 by 7, minus 3 by 7, minus 4 by 7, minus 5 by 7, and this is a minus 6 by 7. And the last one will be minus 7 by 7. The last one is a minus 7 by 7, which is minus 1. Now, where is the rational number minus 3 by 7? From 0, 3 parts together. So this is a position of minus 3 by 7 on a number line. So the point is, you need to understand in between which values your value will be existing and try to divide that into 7 different parts, and from there you need to take a third number. You need to take the third position. Third position is minus 3 by 7. Come from 0, not from the other side. Alright, so let's move forward for the next question. Find any 3 rational numbers between 5 and 6. How to get rational numbers between 5 and 6? So what I'll write, I know between 5 and 6 there are lot many numbers, but it's very difficult to write. So I'll make it so simple. 5 and 6, let us try to make it as 50 by 10 and 60 by 10. Both are same, correct? 50 by 10 and 60 by 10, it is equal to 5 and 6. So now between 50 by 10 and 60 by 10, I can write many numbers. How can I write that? 51 by 10, 52 by 10, 53 by 10, so on till 59 by 10. All these numbers are the numbers between 50 by 10 and 60 by 10, or simply 5 and 6. These are the numbers between 5 and 6. correct? And you can take any three numbers from there. So let's take any three numbers, 53 by 10, 57 by 10, and 58 by 10, or 59 by 10. So all these are the numbers in between them. All these are the rational numbers between them. Not only this one, you can also write 50 by 10 as 500 by 100. 500 by 100, and you can write 600 by 100, and here you have a lot many options. You can go for the numbers in between them as 501 by 100, 502 by 100, 503 by 100. So all these are the things, right, in between them till 599 by 600. In that way you can write unlimited, infinite numbers, infinite rational numbers in between any two rational numbers, correct? Okay, let's move forward for the next one. Find any three rational numbers between 3 and 4 by mean method. By mean method, which is very important. So what is this mean method? What is this mean method? Okay, mean means something like average. You can just relate, although these two has two different meanings later. Okay, but for now you can try to remember as average of two numbers between 3 and 4, right? I'll give you a small example first of all. Between 2 and 4, to get the number between them, we can do 2 plus 4 by 2. What is 2 plus 4? 6. 6 by 2 is 3. So in between 2 and 4, we have a number 3, which we can get from the average of those two. If we have two numbers A and B, the mean A plus B by 2 will always be a number between A and B. The number A plus B by 2 will always be a number between A and B. Correct? So we have a rational number between 3 and 4. So we have 3 plus 4 by 2. 3 plus 4 by 2. So 3 plus 4 is 7, 7 by 2. So this is a number between 3 and 4. 3, 7 by 2 and 4. If you need one more number in between 3 and 4, you can simply find a number between 3 and 7 by 2, correct? This is one number, done. But how many numbers we have? We need 3 numbers. We need to have 3 rational numbers. I told you again, in between these two numbers, we can try to find one more rational number. So that is again using the same mean method. Between these two, you can try to find 3 plus 7 by 2 by 2. And between these two, you can try to find 7 by 2 plus 4 by 2. So these are also the numbers in between them. Okay. So 3 plus 7 by 2, you need to take LCM. Let's try to do that. 3 plus 7 by 2 by 2. So this one, LCM is 2. So it becomes 3 to 6, 6 plus 7 by 2. 6 plus 7 is 13. 13 by 2 by 2. 13 by 2 by 2, which is 13 by 4. The 2 gets reciprocal, becomes 13 by 4. In the same way, let's try to find what is this value. 7 by 2 plus 4 by 2. 7 by 2 plus 4 by 2. Okay. So again, LCM is 2. So 7 plus 4 2s are 8 by 2. 7 plus 8 is 15. 15 by 2 by 2 will give you 15 by 4. 15 by 4. So what are the numbers that I can write between these two numbers? Starting with 3 and 4, we got a number between these two, which is 7 by 2. And again, between 3 and 7 by 2, we have the number 13 by 4, and we have one more number 15 by 4. And in that way, you can try to write as many numbers as you can using the mean method. Once again, you can try to find a number between these two, between these two, between these two, between these two. Right? Again, you get lot many numbers. You can find infinite numbers in the same approach. Right? Okay. Let's move forward for the next question. The mean method is always says that A plus B by 2 is a number in between A and B. A plus B by 2 is a number between A and B. Right. Let's move for the next question. Express 7 by 16 and 2 by 3 in decimal form. Now we are going to discuss about decimal. We discussed in the lower class what is decimals. Once again, let's try to have a recall of that. Decimals means we need to divide. Okay, we need to express that as some decimal points. Let me tell you about 16 by 7. 16 and 7. So when you divide this one, you cannot divide 16 with 7, right? So you need to have one more 0 because it is less than 7 is less than 16. Keep 0 point. If you keep point, you can keep 1 0 here. If you can keep point, you can keep 0 here. So 16 fours. 16 fours are 64. 16 fours are 64. So how much is left? Again we are left with 6. Again, as we already kept one decimal, no need to keep that again and again. Just go with the 0. 16 fours are 64, so we cannot use that. 16 threes we can go. 16 threes are 48. We are left with 12. So I'll give one more 0. So now we need to be careful. 16, how many times? 16 fives, 16 6, 96, 16 sevens, 6 7s 42, 7 1 7, 8 9 10 11. 16 7 is 1 1 12. 16 sevens is 1 1 2, and again we are left with 8. So it is 0, 16 and 80. Do we have any value? 16 fives. 16 5s 30, 5 1s 5, 6 7 8. 16 5s are 80. 16 5s are 80, so we can say that 0.437. 16 5s are 80, right? 0.4375 is the value of 7 by 16. Now let's go for 2 by 3. Let's go for 2 by 3. It's a very interesting question. Okay, 3 and 2. Correct? Again, you cannot divide. You cannot divide. We need to bring 1 0. So keep a point here. So 0 here. 3 6 are 18. 3 6 are 18. So we're left with 2. We're left with 2. Again, 3. Once again, we need to keep 6, or you can keep 0 first of all. So 3 6 are 18 again. 3 6 are 18. Once again 2. Again 0. So 3 6 are 18. And this process will continue so on. So the answer for this 2 by 3 is 0.6666 and so on. It will never end. So can you carefully see some difference between these two? 0.4375, it got stopped there. We got the remainder as 0. But here, even if you go for the next 1 lakh steps, 1 crore steps, you still get the same 6. It is the same 6 being repeated forever. You cannot stop that. Okay. So what happened? Here it stopped. Here it didn't stop. So based on that, we can say decimal numbers of two kinds. One is a terminating. Terminating means it is stopping. Just like the definition which we just saw. It is stopping there. But here non-terminating, just like 2 by 3 value, 2 by 3 value which is a 0.6666 which goes on forever are called non-terminating. Terminate means to stop. The word terminate means to stop. Here it is, there is a stop. Here there is no stop. It continues forever. So decimals again we can classify into two terms, two types. One is terminating. One is non-terminating. Terminating and non-terminating. Correct? So every rational number can be expressed as a terminating decimal or a non-terminating recurring decimal. Non-terminating, recurring means keeping on coming. The same value is keeping on coming, right? That is what we say recurring. Every rational number, just like 2 by 3, or you can have 1 by 2. It is a 0.5. 1 by 2 is 0.5. A rational number can be expressed as a terminating or non-terminating decimals, right? So let's move ahead to see some more applications. A decimal number is said to be terminating decimal if the decimal number contains a finite number of digits after the decimal point. Just now we discussed one example. What is that? What is the value we got? 0.4375, correct? 0.4375. 0.4375. So how many digits we are having after the decimal point? After the decimal point, we have 4 digits. It is a finite value. But if we have something like this 0.5666 and so on, it is never terminating. It is called this is non-terminating. This is not terminating. We say them as non-terminating. Okay. 0.548 fixed. 1 2 3 4 5 6 7. 1 2 3 4 5 6 and 7 digits after decimal. It is fixed. It is a finite value. It is terminating. It is terminating, but here it is never terminating. It is just keep on going on that. Right? Let's go for one more. A decimal number is said to be non-terminating. A decimal number is said to be non-terminating if the numbers after decimal continues endlessly. A decimal number is said to be a non-terminating if the numbers after the decimal continues endlessly. It is just keep on going. It is moving on like this. Endlessly, right? You can say 0.56669766683, whatever the flow it is a non-terminating. It is a non-terminating decimal number, correct? Right. So let's try to move forward. Now let's try to discuss about decimal numbers again, where we have few things: recurring and non-recurring. We discussed terminating and non-terminating, correct? Terminate means there is a stop. Non-terminating, there is no stop. But there is some more information ahead of this one, which is called recurring and non-recurring. Let's try to have small discussion on that, and then we'll stop the lecture. Okay? Recurring and non-recurring. What do you mean by that? See, some cases where recurring decimals are also called as repeating. Can also be called as a repeating decimal. The name itself says that it is repeating. Careful check here. 48, all 4 8s, right? It's the same 4 8 is being recurring or repeating. 4 8 is recurring, right? So this is the number where we can write this as 0.548. Instead of writing all the 4 8s, we keep a small bar like this. 0.548 bar. This bar represents that we are continuously going with 448. We are not stopping anywhere. Okay, the bar represents it is a repeating, or we say recurring decimal. So by this time you might be knowing what is a non-repeating, which does not have any fixed recurring pattern, any fixed repeating pattern, right? So what is that we are having here? A recurring decimal is a decimal number in which a group of figures is repeated infinitely. Group of figures is repeated infinitely. One second. Group of figures is repeated infinitely. You can see here 48 is being repeated. This 0.548 bar. 0.548 bar. Correct? So let's move for one more. Let's try to move for one more, and let's try to see what is a non-recurring. We just saw recurring, which has some fixed pattern which is being followed again and again, but here which no group of digits are repeating endlessly. It is a recurring, that is okay. It is a recurring, okay. A non-recurring decimal is a decimal number in which no group of digits are repeating endlessly. Okay, you can see the examples here. Non-recurring decimal numbers can also be called as a non-repeating numbers. You can see here 0.548, 45799823 some 484579. There is no pattern. We cannot write as a recurring decimal. We cannot have a recurring decimal part. So these type of numbers are called non-recurring decimals. We discussed terminating and non-terminating. We discussed recurring and non-recurring decimals, right? So in the coming classes, we are going to discuss some applications based on this recurring, non-recurring, terminating and non-terminating numbers, and then we are going to discuss about irrational, and then club together we are going to discuss about real numbers, right? Thank you so much, friends. Stay tuned to get the next lecture. Thank you.